Already I've given on. So already I have given one lecture in the logistic regression, which is the part of the machine learning. Okay. So previous we have like statistics we studies before like 5 6 before we study about the statistical inferences. Now that part now converting in terms of machine learning because non-linear regression machine learning, logistic regression machine learning, regression machine learning, like all our machine learning models, they are. The things are different, basic concepts that's given in statistics the same. Things are here, how we apply for given data, and the most of things, the training and testing part. So this comes from the machine learning mm, theory. So first we know about the what is the machine learning. Machine by the nomenclatures. Okay, in this my today's sessions, I'm going my titles. I've discussed about the application to the digital transaction fraud in the machine learning model. So we have I've just pronounced some names there. Linear regression. These are the machine learning models, and we have already discussed about the things how we can apply for the given data. So there be like tomatoes. We have taken example. Today we are consider one another examples, or you can say application in digital transaction fraud, and the very common and we are aware with each and every people, so those who are doing transactions of this fraud transaction. So how so by this model, so how we can detect what is the process behind how we start with the data, how we apply the models, and after that how we find the accuracy something, and then we apply for the other data. And what are the things in this case? It's a very small part. Fraud detection, it not means we apply this model directly to our ATM machine and some our bank systems. It's take not like that. Okay, so means for particulars means how we analyze and how we can trace the detection something because here we taken very limited attributes, very limited variables. Okay, but the bank sector has a when we are applied to the real time system, so we have to include numbers of parameters, numbers of there are many parameters. They have bank and numbers of some OTPs. These are the things are linked with that one. Okay. So, but this is enough. By this model, by taking the example of the digital transaction fraud, we can understand some things using of machine learning. So first we know about what is the machine learning. So machine learning by nomenclature we can understand. Machine is learning, just like our child is learning. Same thing, machine. Machine is what here is not here something. Machine here we not consider is like in the big factory there is a machine we are producing there some items like car and something. It's not only our small computer is also what type of machines we are training the model, training the data, and by applying that model, then it will can So we have some basic we should have a knowledge about the basic information. So machine learning is the subset or is the part of artificial intelligence. So artificial intelligence is very broad, broad in that sense. So machine learning is the part. Broad means AI, like before 10 years or something. So when I was in MSc, so I, there I was study about the artificial intelligence as the elective course something. So we don't know on that times it will include features, it will very hot subjects and they are real things we see based on the okay. So artificial intelligence uh, contains machine learning models, data science. Data science means there is the data frames, the data. Okay, they, they are in the different format, secondary.
Sir, Anup sir. Anup sir. Hello sir. Anup sir, you are muted, sir. Please unmute yourself, sir. Hello. Hello, Anup sir. Hello, Anup sir. Madam, message. Hello, Anup sir.
Am I audible?
Ha, sir. Now you are audible, sir.
Okay. So I was talking about the types of data analysis and descriptive and the analysis of four types when we are about moving for the machine learning models. So we should have knowledge about these four types of data. So first is descriptive analysis, second is diagnostic analysis, third predictive and prescriptive analysis. Descriptive analysis means when the data are given, what data we have. Okay, simply data we have. So we make it some meaningful. So how we make it meaningful? By calculating their average, median, mode, scoring, some other values we are finding by which we can understand is what has happened, something. Okay, so we have marks 2 semesters for first semester and second semester. We are finding the correlation. If we see the finding, the correlation is positive. That means my marks is improving. If the marks is what is down, so marks is what correlation is negative in that case. So simply in the descriptive analysis, what we have a data for the given data, what we have a data for given data, we are simply applying the statistical tools or formula to find to find the values, and on that basis we have a limited information. On that basis we can take some decisions, like we can understand something what has happened in the last month, what has happened in this result, so like that we can know. Next is the dynamic analysis. In simply in this case we identify the cause. So what are the reasons what type of reasons which affect this result. So in this case we are identify this diagnostic analysis. Next is what predictive analysis. Predictive is what might happen. We are predicting. So we have already like linear regressions. We are finding the value of y for given x. So this is the predictive analysis. Already we make the model train, prediction, train and testing done, and after that, from the values of x, we are finding the value of data. We are predicting for other values. Okay, so that we call it a predictive analysis. When the prospective analysis. So in this case, we are going to find that result only. Okay, we are not simply okay. We put this one, we will get this result. It is not like that. I want this, we will have that result. So recommends action optimized strategies. So we have to what we need to change the variable we add or remove so that we get the targeted our results. So these are the types of analysis. It's very important. We should know. So I will define machine learning. Machine learning is a branch of AI that enables computer to learn from data without explicit programming. Okay, means like machine learning, that means all models we are training, and after that, the models its own can understand the data and give the result. Okay, so this is the like robots, humanoid, and some part when you are playing the game. So these are coming under that part. Okay, so who is the author of? So Arthur Samuel, 1959, coined the terms of machine learning. Okay, how we understand mathematically a machine learning work. See the programming means what we have done programming like C, C++. We have the X series. Yeah, we have an X list or array something that is the contain the value 1, 2, 3, 4, 5. So there we writing one y is equal to x plus 5. So y value it calculated as we pass the x value. So y 6, 7, 8, 9, 10. Okay, so these we have done is procedural programming. Okay, this is our procedural programming. Next, moving to the machine learning. So machine learning X and Y both we have a data. So it will what will discover pattern. What pattern is going on so that the next value will come. So pattern in what? So y is equal to x plus 5. It is generated. It is discovered by machine learning model. Okay, so this is pattern is discovered. They work. They discovered the pattern. Like the chat GPT you are using, you are putting something, they are giving the result is specifically. So that means the lot of data background in touch with that chat GPT algorithm. Now, when you type in according to that the word and your previous data, what you have searched, so accurate and that all parts and giving that results. Okay, so these are things how they are doing using this machine learning models and algorithms, language processing. So these are the deep learning. So like that, they are giving that result. Machine learning is also divide. There was we have studied about the analysis. Now we have seen. So learning is also there is the three types mainly. It may be more. Okay, when you study in the deep learning, but in two, three types: supervised learning, unsupervised learning, and reinforcement learning. So in this case, label data we are using. Label data that means when we have a data something, there is the subject name is there, mathematics, physics, chemistry, and their marks is there. One side is the roll number, name is this is called the label data. Okay. So when we these type of data will pass, so this is called we are training our model. It's coming under the supervised learning. So we have already done my last lecture in the logistic regression. This is the supervised learning. Next is what unsupervised learning. Unsupervised is what this in this case. Yes, see one more thing. In supervised learning, we have a regression model. We have a classification model. Like that, we are. Okay. So these are the model means classification. Yes, no, yeah, binomial, yeah, trinomial. Like that, we have it classified. We can also predict or we can find. And regression means like point estimation and interval estimation we can do in the supervised learning. But when you move to the unsupervised, in this case we get into subgroup cluster. In this case also there is the classified output. There may be the cluster. Uh, so by seeing this one, the unlabeled data is there, the mix of this one. So after this models, it make a cluster like something. We have like four types of fruits are mixed up something. So by applying this means when it passes through the models, they have not labeled, so they separate by their shape, by their color. So by this process, they make in two or more than two groups. Like banana, we put the apple, we put the this kiwi. You see, their sizes are different, their colors are different. So based on that, they do. So not need their name actually. Okay, so simply by that model accumulate, they give the result. I just briefly say because things are something more in my semi-supervised. Semi-supervised, that means here we are including 25% supervised data and 75% unsupervised data. So this is coming under the semi-supervised learning. So these are coming under the, means in this case, we have some little bit figures. In some labels include and some labels we don't have. So based on that part, we are improve our accuracy, which before we have the data with the unlabeled, there is no label. So by this process, we will include, suppose we have some clues, just we say we have a clue. By this process, we can increase the accuracy of the data. Accuracy, that means the prediction we can believe at that much. So see the label data, improve accuracy, unlabeled data is the reduced cost. So this is the things here. This is the purpose, semi-supervised. The one is label, improve accuracy, unlabeled that is reduce cost. Because for that one we have to spend time and our like cost investing for learning something. One more is the reinforcement. So reinforcement we can see when we are playing the game. So when our what you say agent or some like characters is moving, okay, and moving, they are getting the rewards and something. As sometimes unable to get the problems, unable to move. So in that case, the penalty will be able to reduce the thing. So we have gone through. So we have gone through many games yeah, little bit like when we are using our mobile, some warning when we are getting a call, some there is spam calls, something. So these are coming under the reinforcement learning. It's like that our model, so the system is embedded with that type of data. Okay. So now in our network, they have added such type of data is converting that with the labels or by labels or not label, but on that process they will respond in that way. So learning by interaction with the environment, like the system is started, the model started, what we get, the data is coming itself, it will learn and response. Okay, no need to provide any label, unlabeled data. So see, we have written here, so no label data in this case, feedback via reward and penalty simply. Doesn't take action to maximize community. So how we understand this type of things? Sound, is it now? Sound is okay.
Yes, sir. Yes, sir. Okay, sir.
Algorithm in such cases, we have algorithm like Q learning, SARS, deep two networks. These are the and application robotics games, autonomous vehicles. So, like a reinforcement is like a autonomous. We can we have something started, and after that, it by itself accumulate the data and work in that part. Uh, Next thing, so we have learned about the before starting the machine learning, we should have knowledge about what the analysis means. Our suppose we are going to project for working for the project. So what label we need to analysis? So that we have completed analysis. We have to that according to that analysis, what type of learning we include. So there is the four types we already included. Okay, so like when we move for the simple um, first, second, so we can apply the supervised, or then we move for the predictive and prescriptive. On that case, we can apply the reinforcement and label semi something. So one one more part is this OSCMN. OCMN is the process by which we collect the data, scrub the data, explore and model and predict. So this is the means this is the path of any project. When you are going to complete a project, in this case, in that project, we include the analysis type of analysis, and we include what type of we train our model, supervised, unsupervised. Unsupervised or supervised learning we include. So briefly, by this figure, we can understand obtain that means we collect the data, either primary data or your secondary data. Scrub that means cleaning, we removing the missing values. Some unnecessary units we change, like we need in meter, there some values are in kg, we need to change there. Explore, that means we find the correlation, we find the some mean values and some distributions. It will explores what type of pattern is their model, then we apply the machine learning model. In this case we apply here ml model, and now we interpret using the output result, the data out data, and we are find what is that the result is there, and how much we can believe, that means accuracy we will find. So these are the something we have written in this case. So obtain means like we have like sensor, we can data surveys, we can APIs, and downloading CSV, query SQL, we can scrub, clean and pre-process the data handling, imputing missing values, standardize feature, scale. Okay, normalization. So these we can do. Explore like EDA means histogram, box plot, correlation like we can do. And E model means linear regression, decision tree. These are the machine learning model. Interpret means visualization, domain knowledge, example, expanding the model outputs to the stakeholders. Means we are just finding the result. CMN is why important, because this is the path is giving in the simple one sentence the path of completing the work. Okay, now we come to the fraud. So what is fraud? Simply anybody any like fraud is the act of deceiving individuals, organizations to gain something value. Usually money is, this is the fraud something. It involves with the dishonest and deceptive methods. So we see have a data something. So in this case, figure of frauds using the card not present CNP transaction in the year 2012 to 18. So we have seen the number of frauds in this form. Frauds like that in the crore and lakh, something is 1,000, 2,000, something is, it will go in the years. So, okay. Something is also very important. Someone people who have earned money in their hard work and they lost within 1 to 2 minutes. So this is the most important to banking sector to how to reduce such type of frauds. So frauds, that means in their system they have to embedded machine learning model so that can save and real time massive real time restriction. Okay, so they so that can apply and restrict the frauds. So in the other way, like us, we can see. So this is about the credit card fraud. Refer to the unauthorized legal. We understand this one. Common types of card fraud include card not present, online, stolen, lost card, identity theft. There are many machine learning techniques widely used for real-time fraud detections. Example, logistic decision tree, random forest, neural network. Neural network coming under the deep learning, and logistic decision, random, these are coming under machine learning. Now we have a data. Suppose we have collected the data. So based on labels, account, age, transaction amount, merchant category, device type is fraud or not. It's like we have a data. So zero is what not fraud and one is what fraud. Okay, so we have like data. So that means we have a first collected data, and we have seen this is our first part is coming under the so analysis, uh, what we first analysis, first stage of the analysis. These are the labels and these are the characteristics of the data collected. So we include here transaction ID, account age, transaction amount, transaction date, merchant category, transaction type, device type, and card type. So their descriptions are given. Transaction ID, unique identifier for each transaction, age of the user's account in days, something. So these are the we have to include when we start the project. We have to write the details something. Same way, transaction location, merchant ID, user age, then fraud, previous transaction, user gender, credit limit, something we include. So after that, in this, we have a data collected with these are labels. We need to here scrub. Okay, we go to that part. So we have opt-in data collected. Now we come to the scrub, and we have analysis we have done like this one descriptive analysis we on that project starting. Now we are moving to the diagnostic something, and next we predictive. Means as we discussion about the complexity of data. So on that part, our analysis part and OCMN mm, uh, flow we follow in this project. So we have already these have shown this part. So this part we by this clean data, cleaning data. So this is what we call box plot. It's very important to clean the data. Okay, in this first box plot you see we have used a transaction amount 0 to 2 lakh something. These are, and next after cleaning we have this data in which we have a 0 to 70,000. So these are what? These are the outliers. These are what? Outliers of the data. So when we remove this outlier, so our estimation of the fraud is the given. Estimation is at what amount possible fraud something. So it doesn't affect our that estimation. Okay, so our data is card not present. That means we are just doing the online transaction. Okay, in our computer, mobile, something. In that case, fraud. No, we consider. Generally, we see why we include the 2 lakhs and something, because in the card we are very less. Generally, people are not doing 2 lakh transaction on card online and purchasing very less. So that's why these are coming under the outliers. So 0 to 70,000. So that means we can remove here. So this box plot, I want to say a little bit explain about this. So this box plot is very important for the cleaning the data. In this case, we remove the outlier. First, understand what is the outlier? Outlier is the extreme values, either very highest value or lower value. So when we draw the box plot, if there is the outliers, there means some extreme values, it will show in the dots in the maximum. So in this case, values are increasing. So this side is there. There is no in the lower. Okay. So money is minimum is zero. So we cannot write in the negative something. But some other data is maybe outliers in the minimum. So when we estimate, so it will, the data is not sensitive, means our tools is not sensitive about this one data. If we remove, so it doesn't affect our estimations. Okay, so this is also used for the goodness of it. We sensitivity about the data. If we include that, means there's a huge fluctuation. Means we are not reached to the better estimation due to this extreme value. So what is the box plots? The box plot simply used to remove the outlier IQR. So Q3 minus Q1. Okay, this Q3 is what? This is the, suppose we have a data. Okay, so here is what Q1, this is here Q2, here is Q3. So these are the values of transaction amount. Q1 that is here is 25% and above is 75% data. So this is the Q1 gives the boundary below which the 25% data, above is 75%. Q2 is the value below which 50% data, above 50% data. This is also called the median. And Q3 is the value below 75%, above 25% data. Okay, So this is the important. So IQR means interquartile range Q3 minus Q1. So that it means we are including only this data. 50% middle 50% data we are including in our system to find. So this line is median. Mean maybe here and here maybe. Okay, but here is not shown in this one. This is our phase. I means like range of this one. So here is Q1, this is Q2, and this is sorry Q3, and this is here Q2. So what it so this you see the size of this both side. Okay, so when the size is same, the this size and this same, that means mean and median are coincide. I most probably almost here in the same place because box so divided equally. Okay. When a little bit something one side is bigger, one side is small, so then we say that the mean is weighted from this median. So almost in this case, mean and median are same. So this range we are including maximum up to these data are including means what the data we pass our model. So in this case, only here to here data we are including that is 75,000, 0 to 75,000. All this data are removed from here, and by removal, if we removing this one, it doesn't affect our estimate. This is the box plot in which we remove the outlier means not useful. Means we have cleaned something. Now we have some methodology. You can say the flow of that one. So we have read the data set, clean and exploitative. Already we have Logistic Regression, KNN, random forest. These are the model we can apply at the same time or one by one. And after that prediction and test the sample data, we have get the this. This is the flow chart something. Now we come to the decision tree. This is the model. In this case, what we have a data. So on that case, one label is become our one label become decision node. Yeah, root node something. Okay. So like root node, suppose we have a data in which the customer name, customer age, and the transaction amount, a vendor, and bank name. These are the labels, suppose. So what could be the decision node? Decision node is amount, obvious. Amount after that, bank or vendor. Okay, like that, the name and something. So by this process, this is the process background data, machine learning data means process there. By this process, decision node, we have a subtree something, and leaf node is tell about each fraud or not fraud, like in which this result fraud or not fraud. Yes. Decision tree, we are unable to discuss about the model, how we apply something. Simply, what we have a data collected after box plot, we now we means clean our data, clean. After cleaning data, the data just like we have discussed in the logistic regressions. So we training and testing Python program which pass, you will get the result simply. Next, we have a random forest. If we know about the random means the random decision tree. So this is the one tree, this is the second tree and third tree. And after that, in random forest, from this all the we have finally yes or no, fraud or not. Okay, so when you study about the random forest, you should have knowledge iterative of the decision tree. Okay, iteration. That means we are reading that part, and the more chances of accuracy, more chances we have a result. Now this is also because we have a data result we need, yes, fraud or not fraud. So other is what KNN. K nearest neighborhood algorithm we say. Its full form is what? Kth nearest neighborhood algorithm. Okay. So nearest neighborhood algorithm we say. Supervised learning means this is also give the result. So in this case, when we train the data, train or testing, so we already make the two groups. Group is what category maybe is a fraud, not, and this is the fraud. Okay, this is the fraud. This is not fraud. So in this case, the when we suppose one transaction is going to happen, it will now all the label it will check the algorithm. So immediately they will what if not fraud? So that means transaction happen. If something is near about these things, this group, so then it will restrict the transaction in that case. Okay. So it's like this Canaan algorithm will work in that way. Next is logistic regression. Already we have a study. In that case, S curve is there. Yes or no case. Okay, what the data? It will find the probability. Probability is zero more than 0.5. Here is the 0.5. Okay, less than it will come to the zero and means here is not and here is a fraud. One is the fraud case. Okay, here this side S, so this is the linear regression. So when we apply such type of data, means we find the accuracy. Okay, there is the R square precision. We given the formula in that part. By that, finding the formula, applying the formula. So we have this getting about the Canaan accuracy 0.95, precision 96, recall, precision 395, 96, logistic regression 1997, random forest 98, 1997. So highest is going on this random forest. Okay, it's the iteration of the decision tree, the obvious. So this model you see means we can accuracy 98%. That means any transaction that is out of 100, 98, the model will means correctly categorize if transaction should be happen or not happen. Precision, accuracy also means like is the given transaction means like they have catching power. Okay, it's coming under the precisions and recall is also about transaction happen, not happen, some on that part. So these are the value, random forest is value. Based on this value, so we say that random forest. But you see, is it we can believe this 98% is accuracy, precision is 98%, recall is 97%. Okay, we cannot believe that much because this is like overestimated. Okay, so what we do, we move for the another algorithm that is called the generative adversarial network again. In this case, this is the generative adversarial class of deep learning models. Okay, because now we are more we are going to apply the complex models. So underlying data distribution, heuristics in the like data sample, they are particularly useful domains where data scarce, sensitivity, and highly imbalanced, such as credit card fraud detection. You see the accuracy. So in this case, consists of two things: a generator and discriminators. Generators create synthetic transaction data and distinguish real data. Fake data means they are also making a mimic data means dummy data you can form. So these are the objective functions. Here is the mathematical by which it will work. Okay, so motivation, these are the other things obvious going in because motivation is that the fraud detection data typically highly imbalanced with the fraudulent transaction form a very small proportion of the data. This is the means motivation. Transaction machine learning model often struggle to learn meaningful fraud pattern due to this imbalance. Okay. So due to this imbalance, so accuracy is giving high, but it is not possible in real life. So for that things further, how we the overestimated, so accurate estimate how we go. So we use this GAN. So in this case, why it is required? This is the unbalance and like less data are there in comparison to that one in this case. So it is enhance the downstream model of such a logistic decision and enhance that one. Again, significantly improve the fraud detection performance by addressing class imbalance, enhancing recall in when robust learning complex real-world transaction data. Architecture is what? Random input factor is data we done, generate the model, come to the binary classification real and discriminator model. Then again, this discriminate, okay, this is wrong something. So it will go to this one. So this one is going on repeat and repeat. And again from this side, generate sample and real example comparison. So we have like some data in this case, the both the real and fake data is also included. So by this process, the data part is increases. Again, working how the first network means the generator has never seen the real data, but it's trying to create data that looks like the real world. The second network that is connected tries to identify whether the data is real or fake. The generator in turn tries to fool the discriminator into thinking that fake are real deal by creating more realistic data over the multiple iteration. So this discriminator tries to outwit generator by continuing refine its own criteria for determining a fake. So what happens? Simple language. What we have data is passed through. So it's not the fraud transaction. They make what one dummy data and keep aside something like that. They have repeat like the data is what repeated. So sometimes what it's coming here, yes, it will fraud. So in this process, they have separated and make the like a number of more artificial data in compared to that one, and on that partial way. So flow chart you can see data process cleaning, training model. This the same thing is there for all the models, same thing. Okay, one to continue. This is the process here, how they are working something. Okay. Uh, They guide each other by providing the feedback from the successful changes. They make their own process in each iteration. The process, the training of the again, training testing also going on the same. Ultimately, this will train the generator to the point at which it can no longer determine which data is real and which is fake. So then, if both the data are included, means we are artificially adding some more data. Okay, this is the gain of the algorithms. Now we have a data about that one transaction, not transaction. So we are check here. You see the not fraud blue and fraud is also because we have added some artificial data. Okay, because there are many means like fraud is also possible at 2,500. Sorry, this is the count. Here it was suppose 2%, and this is 98%. So in this case, we are adding artificial data, okay, on that part and making the fraud and not fraud in similar. Next, synthetic was the original data set. Now we are comparing. So we have the two data set, previous the original, and this is our synthetic. In this comparison, not fraud and fraud due to the GAN. but that was generated through the real data because training and testing is going through the real data. So see in this case, and we have like what we have attributes or clothing, electronics, entertainments on that part. Blue data is the original and synthetic data according to that it will say. Same way, so merchant categories there, merchant category. This is the frequency. Transaction type, ATM, online POS, frequency of device, desktop, laptop, mobile, tablet. Okay, in this case, card type, RuPay, Visa, MasterCard, something. We have to include all the things. Is the where cities there, Bangalore, Hyderabad, Kolkata, something, female and male. So like that, you see the in comparison real data, the fake data means like artificial data is on that way is generated. And now we are comparing means how much on that comparison we is the histogram. Okay, this sorry density curve we have done for the account age and transaction. So we have seen here this one is the mapping here. Okay, blue and that color, this yellow. So the portions are most of the matching. So that means accuracy of data is showing is fine. So after the result, this performance, we have KNN models give the 0.65 precision. Decision tree we have, you see the accuracy level now is decreases. So this is what the estimated value 75. There was 98, 74 here. There was 98, and this is also 97 something. So random forest that means in now in this case we can believe 74%. Okay, in that time we are believing 98. Okay, so that is what overestimated simply. So this is the present GAN-based fraud detection approach that effectively addresses data imbalance by the generative synthetic fraud sample, thereby enhancing the performance of traditional machine learning model and offering the scalable, accurate, and adaptive solution real-world financial fraud. Okay, so what means suppose if you are going to do any project or any work, so like the follow we have to do because we have very limited time according to that timing. We make the like make this work in that form. Because when we discuss about the KNN decision random test is the especially it take the times one hour. Okay. Many things are we process through the model something. So we have shown here by this process, by this knowledge, by this presentation, you can understand how you start, okay, how you process the data, which model you can apply. Okay, it's not necessary you apply the one model. You have to apply at one time more than one, two, three model and see the result, find their accuracy and choose that one. Okay, this model is working. So that model you see is overestimated or underestimated, you check it out. Okay, so then further we apply for the with the GAN model deep learning. The GAN model it will now, if underestimated, it is also beneficial like means accurate estimated and overestimated is there now brings to the down. So by this process, at least we have a result on that we can believe. Okay, it's not 99%, 100%. So that means we have to move for the other data or we change in their formulation and their structure of the models. Okay, so by this process, we can improve. By this process, we can improve our model and improve our accuracy in that case. So these are our some uh, given the brief about all about the machine learning projects we complete using the models and start with the data something. Okay, how we take the and start with the data. If anybody has doubts, something can ask.
Hello, sir.
Yes. Yes, I'm audible.
Hello, Anup sir.
Yes, sir.
Hello. Sir, session is over, sir.
Yes, sir. Yes, sir. Yes, sir. Yes, madam.
So,
Something was tripping.
okay. If you have any query, ask. Participants,